Alright, let's go over this. Ashley, do you need to factor the numerator? What did you factor? What can you factor out? Yeah, x1. Okay, Ashley, if you factor out an x1, what are you left with? Yes. Because x to the first times x to the third, multiplying the same base, you add the exponents. That's x to the fourth. Okay, Ariana. We did step number 1. We answered the question, can we factor anything? What's the second step from yesterday's lesson? Can you cancel anything? Yes. Correct. I like to put a box. Ariana, when you cancel something, what is that called? Vertical asymptote or a removable hole? What should I write in this box, Ariana? Removable hole. So now what else do I write? Oops, sorry. Equals a number. What number? 0. We've been drawing a vertical line, and essentially what happens there is that it's undefined. So in some ways you can also write x is not equal to 0. I'm going to ask a question, think about it in your head for 5 seconds, and then you're going to show me your thumbs, yes or no. Do I need to set the denominator equal to 0? Show me. Okay, so if I look at this problem, after I cancel, this is now my new formula. All I'm really graphing is this. Y equals x to the third. Class, do you have a variable in the bottom there? No. No. So there is no vertical asymptote. There is no step number 3 because there is no variable like an x or x squared, x plus 5, something like that. Okay? So we can write that. Vertical asymptote, none. And hopefully you see that I use lots of colors, and that might help for you when you're doing your graphs. Okay, class, let's apply today's lesson, which is our horizontal asymptotes. Go back to the original problem. Put your finger at the top degree. The degree is the exponent, so I have 4. Class, what's the bottom degree? It is 1. Partner A, tell partner B, what inequality can I put there, and what result do I get from your formula sheet? Let's see, what inequality do I put here? Greater than, equals to, or less than. This is going to be, is 4 bigger than 1 or smaller? So we put greater than. Tony, if I put in a greater than on your formula sheet, what does it tell us as our result? It's not an asymptote, but for the horizontal asymptote, it tells us what? There's none. Let's write that. None. Okay, I don't think you would need to make a table of values. Whisper to your partner, what do you think is the shape of this graph? We already did it for all of last semester. Okay, let's say you don't know how to graph that. Let's make a table of values. So now I'm going to show you how to graph something without using technology. You have your x's and you have your y's. Now a good point to actually start with is your removable hole. So let's go ahead and sketch that in there. You go to x equals 0. That's on the x-axis, and right here I'm going to draw a vertical line. Remember, this vertical line does not represent a vertical asymptote, but is where my removable hole will be. And my removable hole is at x equals 0. From here, class, can you pick two numbers to the left? -2, -4. And what are two numbers to the right? 2 and 4. And I can now use my calculator. You can essentially put in -4 to the third power. As you're putting that into your calculator, make sure you're using parentheses. Super important. Remember, with Texas Instrument, you have to press the negative button first, and then to the third power. You get -64. -2 to the third power. Class, what do you think that is? 8. -8. 0 to the third power? Ah, look at this. Now, I was using the reduced one, and I realized I should have done it in this one, but it will give you the same result. But the 0, the reason why the answer is U, class, what does U stand for? Undefined. The reason why it's undefined, because if you put in 0 here, something divided by 0 is undefined. Remember in our notes the other day? Can you divide by 0? The answer is no. And then these are basically the same thing, but not negative, right? So you can put in 864. Let's use pink. So if you're going to graph this here, so let's review how we graph the rational function. We first see if there is any vertical asymptotes or points of discontinuities. We found one, an RH. Draw any vertical asymptotes or discontinuities. That is our removable hole. Make a table of values. We just did that here in pink. And then it says plot the points and draw the graph. So -4 way down there. -2, something way down there. And then 2 way up there, and then 4 something way up there. And my graph should look something like this. Probably not the best graph, but it's not linear. But the big idea is this removable hole is at 0. So there's a donut hole. And what does that mean? Basically, it means that any point on the graph is defined, right? You can get an order pair like -2, -8 is defined, but the hole is undefined because we just did the substitution and you can't divide by 0. So that's how you get your vertical asymptotes, any domain restrictions, today's new lesson, horizontal asymptote, and then now we're actually graphing this without technology.